Okay, babies, this is going to be your last video for Unit 1 as far as basic information in the notes. And there are several things I want to highlight in this particular video. We're going to focus on the 5-number summary. What is it? We're going to finish talking about range and things of that nature, variance. We need to talk about that. The other two major things that we need to talk about are the outlier test, and we also need to talk about percentiles. But there's some other important stuff in here. This word resistant, that is something we're going to focus on in this video. All right, so when we talk about the 5-number summary, the 5-number summary are just 5 basic numbers that are a part of every set of data, even if you don't know what they are. And they consist of the minimum value, the Q1, which is the first quartile, the median, the Q3, which is the third quartile, and the maximum. And we haven't gotten there yet, but we will after this next set of videos. We're going to talk about box plots, and box plots show off the 5-number summary beautifully. So we will talk about all of those as we get closer to that. Okay, the range and when we use it. The range is a measure of spread, just like the standard deviation and the IQR. And you've probably heard me talk about the range already. So it's basically just a difference between your biggest value and your smallest value. It is the most basic measure of spread, and we only use it if we have no other alternative because we always want to be as specific as possible. So the only time you're really going to use the range as your measure of spread is when you just have the picture or the distribution of the data. So again, when we can calculate standard deviation or IQR, we prefer that over this very basic measure of spread. All right, so the variance is symbolized by this right here, which is essentially just the standard deviation squared. That's all the variance is. Don't get too caught up in the variance. We're not going to use it a whole lot. It's just a mathematical term that we use to indicate that we've taken the standard deviation and it is the standard deviation squared. So as that comes up, we will address more issues with it. Know that sometimes we use it for calculating other values, and that is going to be particularly of value to us later on in different units. But again, I will address that as we get closer to it. Okay, so big idea in this video, outlier test. Well, here's the thing. If you're looking at a set of data, so let's say we have something simple here. Like let's say we're looking at a dot plot. And I'm just going to use 1, 2, 3, 4, 5 here. All right, so let's say we have a dot plot. So I've got these dots on here. Okay, and then I've got this dot out here. Well, when you're just looking at it, it's easy to see that, you know what, this value out here, this 6, that looks like it might be an outlier because there's some space right here between it and the rest of the data that seems to be pretty close together. So if you're just observing it visually, does it appear to be an outlier? Sure, it appears to be an outlier. And as long as you are just looking at it visually, you can say that it appears to be an outlier or it may be an outlier. You cannot say it is an outlier unless you run the outlier test. Okay, Miss Griggs, don't keep us waiting. What is the outlier test? Well, the outlier test looks like this. You take Q3, which is the third quartile from the 5-number summary, and you add to it 1.5 times the IQR. IQR. And if you'll remember from my last instructional video, remember that the IQR is the measure of spread we use for a non-symmetrical set of data, and it is Q3 minus Q1. So it's the third quartile value minus the first quartile value. Okay, the other piece to the outlier test, because there are two parts to it, it is Q1 minus 1.5 times the IQR. All right, now what's going to happen in a set of data when you calculate these things? You're going to get values for them. These values have nothing to do with being a part of your data. These numbers are boundaries, okay? So what these two things do, what the outlier test does, it creates boundaries. Okay, what do we do with those boundaries, Miss Griggs? Well, those boundaries tell you that if I have any piece of my data that lies outside those boundaries, those values are outliers. So as we go through examples, I will show you how to run the outlier test in a specific example. But you have to hold on to this idea that these are boundary values. They are not, and let me repeat this again, they are not part of the data. Because a lot of students want to say, oh, those are pieces of my data. No, they're not. Don't do it. Okay, so that moves us to our next idea in this video. What does it mean to be resistant? Well, as I've stated already, both in our WebEx times and in the videos that I've done for you, resistance means that I'm not strongly affected by extreme values. So if you're resistant to peer pressure, that means that you don't go along with the crowd just because everyone else is doing it. Well, that comes into play when I start talking about values of mean and standard deviation. So remember, I've told you that when we are looking at a data set that has a distribution that is not symmetrical, we want to report the mean and IQR for measures of center and spread. Why? Because those values are resistant to extreme values, which are occurring when you don't have symmetry. The mean and standard deviation, on the other hand, will go right along with those higher or lower values. So those are said to be least resistant. And the standard deviation is even less resistant than the mean. Why is that? Because what the standard deviation does, and if I had written the equation out for you, you would see this mathematically, but what the standard deviation does is it's an equation that takes every single distance from that mean value and calculates it. That means that it is very, very much affected if there's a lot of space between one number and another one. So it is calculating that, and therefore it will be greatly affected by that greater distance between values. All right, that brings us to our last big idea in this video. I'm sorry this video is so long-winded. Oh my goodness. What does a percentile measure? Well, kids, if you've taken a standardized test, which I'm guessing all of you have, you probably know what a percentile is. If you fit in the 50th percentile, 50% of people scored below you. If you're in the 90th percentile, that means 90% of people scored below you. When I say something like percentile, it means always below that value. always, always below. So most of you are going to understand that because that's something you've been hearing all through your high school career. All right, so in wrapping this up, please keep in mind that this last question here, why do we measure variability, isn't knowing the center enough. Well, keep in mind we need to know how much variability we can expect away from that center mathematical value. Please keep in mind there are words here that are synonymous. When I talk about variability, I'm talking about spread. It means the same thing. When I'm talking about a measure of spread, I'm talking about mean or I'm talking about median. Oh, dang it, I misspoke. Shame on me. And I'm not going to redo this video, so. Okay, so when I talk about spread, I'm talking about a specific measure in the IQR or the standard deviation, okay? Another value is range. Remember, it's not as specific as IQR and standard deviation. So when we're talking about vocabulary here, IQR and standard deviation are very specific measures of spread or variability. Range is a very general measure of spread or variability. Keep that in mind. Listen to this again if you have to. I'm so sorry it's so long.